Welcome everyone to the third episode of AVANT-GARDE-GRASP. I hope you all are safe considering the pandemic and the ever increasing number of its victims. I'm your host for this episode, Anukram, and before we begin, I'd just like to give you a brief context into this episode. Now, it was, I guess, a week or so into the lockdown, and I saw the news where two Italians were 3D printing ventilators and supplying them to hospitals. I found it really cool, and a couple of days later, I read another news article where a team from Kathmandu University had achieved a similar feat. Now, though the object in question was not a ventilator per se, it was a 3D printed mask. Nevertheless, it really stirred up my curiosity as to the potential for this technology. That is why, to discuss this matter at hand, we have a special guest with us today. He is an assistant professor in the Department of Mechanical Engineering in Kathmandu University. He is also the in charge of the design lab in the university itself, Mr. Pratisthit Lal Shrestha. We are extremely honored to have you on our podcast here, sir.
Thank you for inviting me.
We are all experiencing something unprecedented, right?
Mm-hmm.
Schools have closed down, offices have shut down, and a lot of things have shifted online. There's also this increasing sense of uncertainty among the population. How has this whole thing, COVID-19 and lockdown that is, affected your daily schedule?
Well, before this crisis, normal day for me would be 7 to 7 rush, but now it has slowed down a bit, and I have enough time to spend with my family, which used to be only on Saturdays, obviously for every Nepalese.
Right.
And plus, these days I can spend some time for my long due projects, like home projects. I think I'm enjoying it.
Great. Now, for me though, there are minor arguments erupting now and then because of being cooped up for so long. I guess it is nice to spend time at home for a change. I guess this lockdown has provided us with a chance to wind down a bit, and I also guess it is a chance to focus on things that we wouldn't have time for otherwise and explore our creativity. Anyways, moving on to the topic of the day, 3D printing. Now, many of our listeners might not be familiar with this. So, sir, could you please provide just a brief overview about the process?
Yeah, 3D printing is quite popular these days. Everybody is talking about it. Well, 3D printing is one of the rapid prototyping methods that can literally print any kind of shapes, which would be impossible with other machines or by hand. Its principle is very simple. It is almost like making a sail roti. Yeah, both works on the same principle. I usually give this analogy. If you have seen sail roti being made, there's a thick paste which is extruded out of a small hole and it solidifies as it dips into the hot oil. 3D printing works almost the same way. Here, instead of the paste, there is a plastic which is extruded and cooled to make a 3D object layer by layer. A single piece of sail roti or a sail ring almost looks like a circle, right? So if you stack a number of sail rotis on top of each other, then it'll look like a cylinder. That is exactly how a 3D printer works. The idea is to stack multiple layers on top of each other to form a 3D object. However, it is not as easy as printing text on a paper. There are a lot of parameters to understand and a lot of variables to consider, and here the experience counts. You might need a bit of skill while printing, or let's say 3D printing. In market, you can find like 3 different types of printers: FDM, SLA, SLS. Out of which FDM is the most popular one, and yes, the cheapest one as well. Some of these work on the principle of fuse deposition, and some uses laser to cure. Or whatever be the type of the printer, the basic concept remains same for all kinds of 3D printer. To 3D print, you'll have to first 3D model the object that you want to print, and these can be done in any kind of 3D modeling softwares like SolidWorks or CATIA or any 3D modeling softwares. The 3D models that have been made in These softwares have to be saved in a particular type of file which can be readable by these machines, and these files can be printed on those printers.
For those of you listening and who do not know, I had mentioned this earlier as well. This team at the design lab had recently produced a prototype 3D printed mask, but it was, as I said, a prototype. I just wanted to ask, sir, has there been any updates to this, any research that has been done to test its effectiveness, or any large-scale production projects?
Thank you very much for bringing that up. The 3D printed mask was one attempt to make people familiar about 3D printing technology and its usability, especially in the situations like we are facing now. There are a lot of free designs of 3D printable masks available easily in the internet. We picked up one of the most simple design. We studied it, put our thoughts together, and modified it a bit. But unfortunately, before we could take it further, lockdown happened, and because of lockdown, we couldn't test it properly and carry on with the idea of mask. However, we have been studying pros and cons of such 3D printed mask and trying to update the design to make it more safe, more sterilizable, and mass producible. There are a few problems with most of the 3D printed masks that needs to be addressed. Like first is its effectiveness, whether these masks actually work as a mask, and whether they are able to block the particles or the viruses and all. Then the filter materials, sterilizing methods, and finally its cost. As I said earlier, 3D printers are a type of rapid prototyping machines. As its name suggests, it helps to produce, or let's say the prototype, a design, but mass producing in it might not be a sustainable idea until now. It will be definitely expensive. So we have been planning for upgrading the mask design and its manufacturability, as well as a testing facility to test its effectiveness. Probably once we regain the access to our lab, we'll continue our work on it.
We all know, right, and we have quite clearly seen it as well, that this pandemic has exposed a lot of flaws in the healthcare system both in Nepal and abroad. Now, one of the main concerning things that I find about this is the lack of PPEs and ventilators in hospitals, because I always thought that these were like the fundamental tools that you use to tackle situations like these. But the shortage just clearly highlights how unprepared we were from the start. Now, I had mentioned the Italians 3D printing ventilators earlier, hadn't I?
Yeah.
And I'd just like to extend the concept a bit and ask whether this technology in its present stage of development has any scope of producing these devices to meet the demand in hospitals.
This pandemic has definitely shown our status in many ways, and especially in the preparedness in healthcare system. In situations like this, 3D printers can be a very good option to produce devices or parts of the machine. In fact, it is already being practiced throughout the world right now, especially for the production of face shields, masks, air savers, nasal swabs, and many more. Some of them are using it to fabricate parts of mechanical ventilators as well, and even in Nepal, a number of makers and individuals are doing it. I highly appreciate all the people who have been working on to fight against this crisis in their own ways. This is precious.
Now, before we move into discussing about the design lab, I'd just like to ask you a last question about this topic, 3D printing.
Yeah.
This is more personally inclined as well, because I just started learning Blender, 3D modeling software for those who do not know, and I wanted to know whether a skill of 3D modeling can be useful in the future for amateurs who are not necessarily engineers.
Blender is a very powerful tool. It is good that you're learning it. There are a lot of things that can be done using Blender, 3D modeling, sculpting to animations, and many more. Though we practice SolidWorks in Design Lab, Blender is one of our favorites, and probably will be using it more in our lab as well. Well, 3D modeling has a lot of benefits and applications. One of the most important aspects is that it helps you visualize things that are virtual or not visible to your eyes. And for example, let's say if I ask 10 people to imagine an apple, probably they'll imagine 10 different types of apple different size, shape, color. But if I 3D model an apple and show it to 10 people, probably they'll see the same apple with same size, shape, and color, and all the attributes. And that's the power of 3D modeling. Now, you can bring your ideas to virtual reality, test its functions and its strength, even without fabricating physically. You can put your ideas very strongly and clearly to the audience. 3D modeling seems like a new word, but it's nothing new. It's only the digital version of what we used to do in our childhood with clay or dough. Like we used to make houses and idols of clay. Yeah, that's 3D printing is 3D modeling is only its digitalized version. You do not have to be an engineer to find application of 3D modeling. There are a lot of applications of 3D modeling in almost all the fields. For example, let's say in medical field, if you need to perform a surgery and add an implant to one's body, 3D modeling can be very helpful. Through 3D modeling, you can custom design the implant and even plan your surgery beforehand. With a proper 3D printer, you can even print those 3D modeled implants in titanium. And fingers crossed, if everything goes right, Design Lab will soon be able to provide that service of 3D printing in metal.
That is a great news. I'm certain that the technology will be put to its maximum use. Now, whenever I tell people about me being a medical student, I am fairly sure most of them imagine me dissecting cadavers the entire time. It's obviously not true. Anyways, I guess it's the same for the design lab as well because the name itself sounds pretty cool. But most of us are not familiar with what exactly happens there, what kind of projects are there, and what kind of designs are made. Could you just describe your typical day at the lab?
As the name suggests, Design Labs work primarily hovers around design. Well, there's no specific definition of design in Nepali. Design for an engineer may be going through numerous calculations, and for a painter, maybe a painting, and for a fashion designer, it may be a new piece of cloth. For a sculptor, it may be a sculpture, and so on. And overall, design means creating something that can be used to solve specific problems or fulfill needs. That is what Design Lab focuses on. Design Lab not only helps an individual rapid prototype their ideas for the proof of concept, but also does the technical incubation to help them make their product user ready. Well, you can find most of the abandoned things of cave in our lab, and we usually open them up or break them, try to learn from it, understand it, and try to fix them again. And the good thing is, no one is going to scold you for not being able to fix it again. The principle behind is to innovate. And to innovate, we need to first understand, or let's say, we need to be first familiar with existing technology. Most of the time, students and researchers come up with some random idea and they say, "Sir, यस्तो हुँदो रहेछ, यस्तो बनाऊँ न त हामी." And I say, "हो र, गरिहेरौँ न त." That's all what we do in our lab, learning through innovation.
While we are at the topic of the design lab, could you please share with us the history of the design lab and how it came to be?
Formally started Design Lab last year, but the concept of Design Lab was there from long back. As a student in the same department for around 16 years back, and now as a faculty, I've witnessed many wonderful engineering projects by students. They were excellent for the academic project, but when they tried to convert it into a startup and try to sell those products, most of them didn't succeed. We tried to dig into its reason and found that major reason was the human factor. They somehow missed to understand the human need. After all, the product has to be used by humans in the end, right? So, if we do not consider them, product will definitely fail. Humans needs to be kept in the center of designing. We need to empathize them. So, to put this concept of human-centric design into action, we put forward the concept of Design Lab. And you might have heard about business incubation. where a startup is incubated unless it becomes strong enough to take off on its own. Similarly, technology incubation is the heart of Design Lab. Design Lab incubates the technologies and those projects to make them market mature. Well, we started this lab by bringing together all the resources in our department relevant to the product development and technology incubation. Like we brought first industrial grade 3D printer from TTL, which was bought in 2011 and is interestingly Nepal's very first 3D printer. Similarly, we shifted a tabletop CNC lathe and a milling machine from our own department. Later, we bought 4 new 3D printers, and the process of adding such state-of-the-art machines is going on and will go long the future. I'm sure in a few years, Design Lab will be well equipped with all those top-notch devices to facilitate the whole nation. It has been only a year of Design Lab, but we have a long way to go.
I managed to go through the website of the Design Lab earlier, and two student projects really caught my attention. These were bionic and prosthetic hands. Now, for those of you who do not know, the core difference between these two is that bionic involves electrical circuits that can mimic neural signals, so that you'll be creating an organ that can mimic the functions of the organ it is replacing.
Right.
Now, I know it has a long way to go in the case of Nepal, but what are the prospects of it being used in medicine? And are there any efforts being done for this?
For that, I'll have to go to how it all started. In 2017, through Professor Beam Shrestha, I was offered a fellowship by a UK-based charity named Health Exchange Nepal, HEXN, to visit Specialist Mobility Rehabilitation Centre SMRC under Royal Preston Hospital in Preston, UK. I spent about 6 weeks there working together with the rehabilitation experts and manufacturing staffs. There were a few moments that touched my heart while I was there. There was an ex-military who lost his both lower limbs in a war. He came to the center in a wheelchair and got his prosthetic legs done and left walking almost like any normal person. And that scene was pretty amazing. And also the happiness of a 5-year-old child who was able to move her hand for the first time after receiving prosthetic. There were so many stories of true impact to motivate me towards this prosthetics. That's how the idea to work on prosthetic began. Many advanced prosthetics are available in the world right now, and the problem with them is they are pretty expensive. One of those advanced prosthetics is a myoelectric hand. It is more or less like a mind-controlled hand, but with slightly less accuracy. Such hand would cost at least 5 to 6 million Nepalese rupees, or even more, and that's way above our reach. So when I came back to Nepal along with my some students, we planned to design such devices which could directly impact people's life and could be produced in Nepal with much lower cost. In the meantime, there was a news about mechanical 3D printed hand for children, which was being distributed free of cost by a charity organization named Enable Nepal. Enable Community is an international charity community, and Enable Nepal is part of it. With initiation from Professor Bolathapa, we collaborated with Enable Nepal for 3D printing mechanical prosthetic hands in our lab. And with that, we had one student, one hand initiative conceived, in which every student of design and manufacturing subdivision of mechanical engineering would be trained on 3D modeling and 3D printing of prosthetic hand as a part of their academic practice, or let's say the laboratory practice, and then get connected with a child with hand amputation. Our students would learn 3D modeling and 3D printing, whereas the 3D printed hand would be later provided to the paired children. All the printing costs that would be required for this would be borne by the department, and this overall process gave us a solid base for our aim to work on bionic hand, and the work in the bionic hand is still going on. Apart from prosthetic hand, we are working together with medical personnel from hospitals on some devices for rehabilitation and gait analysis. Uh, all of them are done more or less using 3D printing. Well, the interesting thing about 3D printing is that it can easily print complex and interlocked objects with almost same effort as we would for a simple object. It saves time and definitely the effort that you have to apply. There are a lot of possibilities in medical field. One of the most popular areas in Nepal is dental. Apart from that, internationally, people have been 3D printing costume casts, implants, model for surgery planning, surgical guides, and many more. I see a lot of opportunity in medical 3D printing.
On a related note, recently the Design Lab had organized a collaboration between the School of Art and the Department of Mechanical Engineering to provide an overview about enameling.
Right.
Is it possible for similar interschool collaborations, for example, the School of Medicine or perhaps Science, to better work out with the production of bionics, or conversely get the students of science or medical science be better acquainted with the technology?
Mhm. My understanding is that whatever we design or make, we do it to solve the problem or fulfill a need. And when we actually start solving problems, we realize that we cannot do it alone. Let's take an example of a car. It is one of the best inventions till date, right? So if you go to buy a car, what did you look for? Is it only aesthetics, or is it specifications, or both? The answer would be both, right? So the both are equally important. Aesthetics demand School of Arts, and specification demands School of Engineering. That's the synergy what we are trying to achieve. Uh, we have been working constantly together with School of Art since 2012, when we first organized an event named Art Engineering. Back then, Design Lab didn't exist. It was an approach to bring together both these schools, along with their faculty, students, resources, and techniques. Continuing the same culture, we had this workshop in enameling this year for the faculties and students of arts and engineering. Well, enameling is a process of coating thin layer of glass on metal, especially copper, or kind of glazing on ceramics. You might have seen shiny old metal plates coated with some beautiful patterns, or some jewelries, or some ceramics as well. As I had mentioned earlier, we are also working together with some medical personnel as well for the bionic hands and other rehabilitation devices. For the last 2 years, we had this collaboration with School of Medical Science through study abroad program of bioengineering at the University of Washington, USA. Every year, the students and faculties from Washington visit us, and they work together with engineering students in Medical Hospital and Design Lab. They try to identify the existing problems, and try to propose some solutions, may it be engineering or kind of other solutions as well. And lately, just after the lockdown, a small team of engineers from Design Lab worked together with the medical practitioners from different hospitals to develop a prototype of mechanical ventilator. We have completed the first stage of prototyping it, but again, due to inaccessibility to the lab and other resources, it has halted our work for now. We have been getting inquiries from medical students as well to work in Design Lab, and they're always welcome. In fact, Design Lab is open to all the stakeholders.
Now, as we come to the end of our podcast, sir, do you have any message to our listeners who might perhaps be interested in this technology, and how projects like the Design Lab can help them?
I'm glad I could share some insight of 3D printing and Design Lab for this. Though Design Lab is under engineering, anyone from any of the schools is welcome to our lab. If you have any kind of project in your mind and feel that design lab could be helpful, do visit us. And currently we are working on a few projects on biomechanics, prosthetics, and its control system design, sun-powered rural cold store, manufacturing of Francis turbine, casting technology, and some others. You can find more in our website, designlab.ku.edu.np. If you feel interested and want to know more about the project and get involved in it, you can always let us know. There are several institutions working in the field of 3D printing throughout Nepal. Many of them are in Kathmandu, like Genotech, Promic Minds, RAN, National Innovation Center, and some others, I guess. 3D printing is an interesting technology, and you do not need any specific degree to get involved in it or to know it, to learn it. 3D printing is the future of almost all the field, including medical or engineering or arts. So be in touch with the future.
Thank you, sir, for your time and your expertise on 3D printing. And thank you, everyone else, for tuning into this episode of AVANT-GARDE-GRASP. We have reached the end of this episode. We will be back soon with another episode. Till then, stay safe. Goodbye.